Let's discuss few things on work and then we'll solve a problem. So we have already discussed that if there's a mass sitting on a surface and if you apply a force F which makes an angle theta with the x-axis such that you move the mass by a distance d, then the work done by this force is F d cos theta. If we have, let's say, more than one forces acting, let's say you have one force like this, another force like that, this force is F1, this force is F2, it makes an angle theta 1 and the other guy makes an angle theta 2. Then work done is going to be F1, again we move it by distance d, then work done will be F1 d cos theta 1 plus F2 d cos theta 2. So the two works just add up. This is the work by the first force, this is the work by the second force, and the two works add up. Let's take a special case when you have an object and you apply a force F along the x-axis, but now you have friction present, and let's call this friction Fr. Now what is the work done? Now work done is going to be, again forgot to mention that you move it by distance d, so it's going to be Fd cos 0 because this force is making an angle 0 with the x-axis, plus Fr d cos of 180 degrees, right? Because this vector is making an angle of 180 degrees with the x-axis. This is 180 degrees. And if you write this down, you see cos 0 is 1 and cos 180 is minus 1. This turns out to be Fd minus Frd. So work done by the friction is negative, which makes sense because friction always opposes work. If you try to move things, friction will oppose. So the work done is negative by friction. Okay, so this was pretty straightforward. We can actually find frictional force also by just drawing free body diagram. In the y-axis direction, we know there is a normal reaction acting, force of gravity is acting downward, and if we find the sum of forces n minus mg using Newton's law, which says sum of all the forces in the y direction are going to be may, and this is sum of forces in the y direction because y direction is up, and this should be 0 because there is no ay in the y direction. And that gives us, we already have done this exercise, mg, and we also know Fr is given as mu times n, so that gives us mu mg, where by mu we mean friction, kinetic friction, coefficient of kinetic friction, because things are moving here. Okay, that means W is going to be Fd minus mu k mgd, right? Okay, that was a straightforward example. Let's take a little more difficult example. Let's say you have a mass, but there is a force F acting, and this force F makes an angle 45 degrees. Also the mass m, and there is a friction force Fr, right? Now how will you solve the problem? Well, using the same logic, we know, let's give other variables d, let's give them values. So F, let's say, is 20 Newton, m, let's say, is 2 kilograms, d, let's say, is 2 meters, and mu k, let's say, is 0.2. So what is the work done by the two forces? Well, by the force, friction is there anyway. So the work done will be F d cos theta minus FR D, right? What is F? It's 20. What is D? It's 2. What is cos 45? It's 1 over square root of 2 minus FR times 2. And this is work. So work is going to be 20 square root of 2, root 2 square root get cancelled, minus 2 FR. Okay. Now FR, what is FR now? You really cannot use this FR now because things are different. To find FR, again you have to make free body diagram. And if you make free body diagram, you observe that there's a force of gravity acting downward. There's a normal reaction acting upward. But also you see this force is not really aligned with any of the axes, where we already sort of assumed that this was the x-axis and this was the y-axis. This force is not aligned with any of these axes, so we can break them apart, and we actually in fact already have broken it apart. The f cos theta part is doing the work, and f sin theta part is in this direction. So f we already have broken to be f cos theta, and this part is f sin theta. Okay, so there's an additional force acting upward, which is F sine theta. And if you write Newton's equation, what do you get? F sine theta plus N minus mg should be 0 because there is no acceleration in the y-axis direction. Well, let's put in the values. We get 20 multiplied by 1 over root 2 plus N minus, for the sake of simplicity, let's take g to be 10 meters per second square, minus 20 equals 0. And if you solve this, you will see that this turns out to be 20 minus 10 root 2, right? So now let's put in this value of N to find friction force. The friction we already know is given by mu k n. This is the kinetic friction. Mu k is 0.2, so n minus 10 root 2, and that gives us 4 minus root 2. And if you put in the values, we get 20, work equals 20 root 2 minus 2 times 4 minus root 2, right? And that gives us 18 root 2. You can see how this algebra works out, minus 8. The work, the units for work are joules or J. You can actually also see the unit for work is actually Newton multiplied by meter. Force is measured in newtons, D is measured in meters, so actually joules is nothing but Newton meter, right? Okay,